Okay, law of sines part two. Right. So before the quiz, the last thing we did was we introduced the law of sines. But you might remember, let me just go back. Right. At the very end, we talked about how we can't use the law of sines for certain situations. Right. So the law of sines cannot be our only strategy for solving non-right triangles. Okay, so the specific situation we're going to cover today is SSA, which recall means you are given two side lengths and an angle, but not the angle between them. Okay, so it's different from SAS, where the angle's between the two sides. SSA means the angle is not between them. And specifically, the angle you're going to be given today is an acute angle. All right, so between 0 and 90 degrees. Okay, so in order to understand this situation, so you're going to be given capital R. Remember, capital letters are points or angles, and then lowercase letters are side lengths. Okay, so you're given, again, one angle and two sides, and that angle is acute. Okay, so right now we're just going to refer to these as capital R, lowercase s, lowercase r. Okay, so let's go ahead and draw a diagonal over here, and then a sort of a flat horizontal side. Okay, so this will be our given angle, right? We don't get to choose this angle. The problem gives it to us. Okay, now the problem also gives us a side length, lowercase s. So let's call this one s. Okay, so again, we had no choice of this. The problem tells us what measurement to use for s. And they also tell us lowercase r. So this one is not lowercase r, because remember, the same letter, capital and lowercase, are across from each other. Okay, so this side over here will have to be r. Okay, so right now we'll just draw it like this. Okay, so again, this is SSA. You're given two sides, but not the angle between them, an angle not between them. Okay, so let's label capital R is the given acute angle. Jumping over here, lowercase r is the side opposite the given angle. And lowercase s will be the side adjacent the given angle. Okay, so with these three things, let's quickly review how to find the height h. Okay, so let me just redraw it real fast so that it's not too crowded. Okay, so let's say we wanted to find the height of this triangle, which we call h. Okay, so we have to start from capital R. That's the only angle we have. We need to involve h, the height, but we can't use the bottom side, right? Because we don't have any measurements there. So we can't do cosine, we don't have the adjacent side, and we can't do tangent, right? Our only choice is opposite and hypotenuse, which is sine. Okay, so sine of capital R would be the height over s. Okay, and then whatever s is, whatever this hypotenuse length is, you would multiply both sides by it. And that would let you determine the height of the triangle. Okay, so we're going to be doing this several times. So that's why I wanted to review it. Okay, so you see below, we've got this like flow chart looking thing. Okay, so you know how flow charts work, right? You follow the branch that follows the situation. Okay, so the first thing you're gonna do, by the way, when do you use this flow chart? That's important. You only use this flow chart for this very specific situation. When you're given two side lengths, an angle that's not between them, and that angle is acute. Okay, there's a reason that we haven't seen this flow chart until now. I've never given you this specific situation. Okay, so that's why we never had to do this. Okay, but from now on, we now need to start checking, is this SSA with the angle acute? If so, we will now go through this flow chart. Okay, so in this situation, the first thing you do is you compare lowercase r, the opposite side, to h, which is the height. Okay, so why are we doing this flow chart? It turns out that when it's SSA with the A acute, there's multiple different things that can happen with your triangle. Okay, so we talked about how like for SSS, there's only one possible triangle, but for SSA, we'll see what happens. Okay, so when you compare two numbers, the opposite side length and the height, three things can happen, right? The first possibility is what if they are exactly equal? Okay, so let's draw the situation. Okay, so let's start with the point R in the bottom left corner. Okay, so remember, I am telling you what capital R is. You don't get to choose the angle. Okay, and we know the angle determines like how wide it is. Okay, so what we're gonna do is we're gonna draw a dashed path horizontally because I'm not telling you all three side lengths. I'm only telling you two side lengths. So we don't know yet how long this bottom side is. Okay, we know it has to go along this path in order to have the correct angle, but we don't know the actual length. Okay, so I told you angle R. I'm also telling you side length S, the adjacent side. Okay, so you don't get to choose anything about this side, right? Because I told you this angle, so you don't get to choose the direction. And I'm also telling you the length. Okay, so now the third piece of information I'm telling you is the opposite side length. Okay, so here's where, things get interesting, right? Because like this, let's just say that this, use a different color. Let's say that this was the third side length I gave you. There's different ways you might try to form a triangle, right? You know it has to connect up here, but I didn't tell you what angle it connects at, right? So it might potentially go like this. It might potentially go like this. It might potentially go like that, right? So that's why we have this flow chart to figure out what exactly is happening. Okay, so we'll get there in a second, but let's go ahead and draw on the height first. The height, we do not have a choice. The height has to go straight down from the end of this side to the bottom. Okay, so this first situation I want us to look at, what kind of triangle is formed if the opposite side R is exactly the same length as the height H? Okay, so with the magic of technology, I can make sure that I do the exact same length, right? So I just literally copy pasted this. Let me just change the color real fast. Okay, so what triangle can I form if the opposite side is the exact same as the height? Okay, so if I swing out like this, I can't form a triangle because I have to hit this bottom path or else the angle will be wrong. Okay, I can try to swing inward, but again, I can't hit the bottom. Okay, so actually the only way I can form a triangle is if I overlap the height, right? So if this is the case, if the height and the opposite side are the exact same, that means that the triangle that's formed would have to be a right triangle. Okay, so there's only, again, one way to do this. There's only one possible triangle. And that's if it's a right triangle. Okay, so if you do the calculation to find the height, and you find that for SSA with the A acute, the opposite side is exactly equal to the height, you now know that it's going to be a single right triangle. Okay, so let's jump over here. What if R is less than? By the way, just a reminder with inequalities, I'm sure you've heard like the crocodile wants to eat the bigger meal, right? So H is bigger than R. Okay, so if H is bigger than R, then R is less than H. Okay, so what if the opposite side is shorter than the height? Okay, so let's again draw. Okay, we start with angle R again. We again don't know exactly how far the bottom side will go, but we do know that it's somewhere along this path. We're given side length S, so we don't get to choose that. And we don't get to choose the height either. Okay, let me dash the height actually. Okay, so I want to see what happens if the opposite side is shorter than the height. Okay, so this is the height. So let me do something clearly shorter than it. Right, so here the opposite side would be shorter than the height. Okay, so let's see what happens when we try to form a triangle. We know it has to connect up here, right? So if you kind of swing away, you're too short to reach the bottom, right? So this does not form a triangle. Again, you can try to swing in, still too short to reach the bottom. And in fact, even if you go straight down, which gets you the furthest, you're still too short to reach the bottom. Okay, so actually, if you ever get these measurements, there's no possible triangle. The third side is too short, or the opposite side is too short to reach the base. Okay. Okay, so let me show you this animation I found. Okay, so here's an SSA situation, right? I told you this side has to be 5.3, this side has to be 16, and this angle has to be 30 degrees. Okay, so again, we don't know exactly where this bottom side ends, just that it has to go along this path. Okay, so right now, the opposite side, which is they're calling A, we call it R, you can see no matter how you swing it in or out, it's too short to reach the bottom, right? So no possible triangle is formed. Okay, so what if that opposite side were exactly equal to the height? Okay, so if it goes straight down, then you do form a right triangle. Okay, so those are the two situations we covered so far. Okay, but now let's go to the middle. What if R, the opposite side, is greater than the height? Okay, well, maybe you can guess from the fact that there's another step to this flowchart. There could be one or two possible triangles. Okay, so how do you know? You have to do a second comparison. Now compare R, the opposite side, to S, which is the adjacent side. Okay, so we're done with the height for now, but we're still using the opposite side length r, but we're using the adjacent side s. Okay, so let's go over here first. Okay, so what if we first compare r to h and we find the opposite side r is longer, then we compare r to s, we find the opposite and adjacent sides are equal in length. Okay, so let's start over here. Okay, so we're always going to start this way, right? We have an angle in the bottom left, an unknown length on the bottom. We have a given side length s. Okay, we don't need to draw the height this time because we're not using h anymore. Okay, so again, here I want r and s to be exactly the same length. Okay, so for me, I can easily do it. You guys can like maybe use your fingers to sort of gauge the rough length. Okay, so what kind of triangle can I form if r and s are the exact same length? Again, I copy pasted it, so you can verify here, r and s are the exact same length. Okay, so I know it has to connect to the top. Okay, so if I go like straight down, it doesn't work. But if I keep going outward, oh, maybe a little more. Okay, how do I make that go away? Okay, so I can form a triangle, right? I have the correct side length and it lands on the bottom path. Okay, so what I'll say here is I'll say that swinging out or outward works. Okay, we are able to form a successful triangle by, again, from vertical, we swung that side outward. Okay, so now we're going to try swinging inward. Okay, so yet again, let's set up the given info. Okay, so again, if you go straight downward, it's too long. It cuts through the bottom. But can we form a triangle by swinging inward? Let's try. Okay, swing inward, still too low. Swing inward, still too low. Swing further inward. No, that's two sides overlap, which means no triangle is formed. And if you swing further out, you don't land on the bottom. Okay, so again, if you try to swing inward, it doesn't work. Okay, so let me this. Okay, so okay, so again, hopefully you see visually how no triangle is formed, right? It's just a line on top of itself, which is not a triangle. Okay, so here's our summary. So to get to this path, remember we first had to come here. Okay, so r was greater than h, but then r was equal to s. Okay, so in words, we'll say if the opposite side is greater than the height and the opposite side is equal to the adjacent side, we show that there's only one possible triangle, right? This way doesn't work. Okay. So now we'll move to the middle. So don't forget, we still had to do this check. We still had to do the opposite side versus the height, but now we do the opposite side versus the adjacent side. And this time, let's consider what if the opposite side is longer than the adjacent side? Okay, so yet again, we'll start with our same little partial triangle. Okay. So this time I'll make sure that I'm gonna make this one a little bit bigger. All right, there we go. Okay, so can I form a triangle like this? All right, if you go straight down, it's way too long. Okay, what if I swing outward? Can I form a triangle that lands on the bottom path? Yeah, how do I make that go? Okay, so okay, a little too much. Okay, so remember this bottom path I can extend a little further if needed. Okay, so yes, we are able to form a triangle by swinging outward. Okay, how about swinging inward? Okay, so again, if you go straight down, it cuts through the bottom. What happens if you swing in? It still cuts through the bottom. Okay, and you might ask, well, can't you go over here and then connect up the triangle over here? Okay, so what do you guys think? Is this allowed? Yes. So it's actually not. The reason is, remember, you're given angle capital R. You're told this angle has to be this wide. If you go the other way, it's not the same angle. Okay, so this does not work. Okay, so here we'll say that okay, so we'll say that swinging in does not work. Okay, so our summary here, again, first we compared the opposite side and found it was greater than the height. And then the second thing is we compare the opposite side to the adjacent side. Okay, and oh wait, sorry, I mislabeled these. Right, the opposite side has to be the same letter. Sorry about that. This should have been R and this should have been S. Okay, sorry. But yeah, now the opposite side is longer than the adjacent side. Okay, so this also leads to one possible triangle. Okay, so there's only one possibility left, right? So the astute among you can probably predict what's about to happen. Okay, so our last situation is what if first the opposite side is greater than the height, but then the opposite side is shorter than the adjacent side? Okay, so let's start again with an angle R in the bottom left, an unknown side length on the bottom, a given side length, I did it again, sorry, a given side length lowercase s as the adjacent side. Okay, so now we said we want the opposite side to be shorter than s, but it can't be like this because don't forget, it has to be greater than the height still. Okay, so here the opposite side is in between the height and the adjacent side. Okay, so I think it would probably be, it's a little bit shorter than this, but not that much shorter. Okay, so let me just shrink this a little bit. Okay, there we go. Maybe a little more. Okay, so let's see if swinging outward works. Okay, if you go straight down, it's too long. But if you rotate outward, rotate outward, rotate outward, maybe a little more. Okay, you are able to form a triangle. Okay, last one, same setup. Okay, again, you want R to be slightly shorter than S. Okay, so again, downward is too long, but if we swing inward, we actually can form a triangle. Okay, so again, hopefully you saw I literally copied and pasted this side over here. Okay, so with the exact same measurements, right, you notice angle R is the same for both of these triangles, right? These open the same width. Angle S is the exact same length. Oh, sorry, side length S is the same, and side length R is the same. Okay, so these two triangles have the exact same measurements for those three aspects. Okay, so the summary here. If, remember, we had to do this first. If the opposite side is greater than the height, and the opposite side is less than, so shorter than the adjacent side, there's going to be two possible triangles. Okay, so let me go back and show this animation again for a second. Okay, so again, what if I make the opposite side just a little bit longer? Okay, so you can see that as this other side, the opposite side swings back and forth, it can form two different triangles, right? Either way, angle A is always 30 degrees. This adjacent side B is always 16, and this swinging side is still always 9.5, but it can either form this dark shaded triangle over here or the entire triangle over here. Okay, so again, these two triangles have the same SSA with the A acute. Okay, so yeah, this is known as the ambiguous case. So if you know the word ambiguous, it means like it's unclear, it can be more than one thing. Okay, so when this happens, we will have two different triangles. So we'll do both. Okay. So before we continue, are there questions on anything that we've gone over? Okay, please turn to the back then. Okay, so here we're asked to solve and find the area. Okay, so notice we're given two sides, the angle that's not between them, and that angle is acute. Okay, so we do need to do our flow chart for this problem. Okay, so again, I'm gonna just always keep drawing it the same way. Okay, so this time the angle is given as 40 degrees, and that's called capital A. The adjacent side we can call B as 15. This means feet. Okay, and then again, we don't know the opposite side, 12, if it swings in or out. I'm just going to draw it outward for now. Okay, so again, hopefully visually you can see this is SSA, and that angle is acute. Okay, so that's why we need to do the flow chart. Okay, so let's remind ourselves, how do we do the flow chart? First step, compare the opposite side to the height. Okay, so the opposite side we already have. The opposite side is 12. Let's find the height. Okay, so we would do sine of 40 degrees equals the opposite h over the hypotenuse 15. Okay, multiply both sides by 15 to get rid of the denominator. Okay, now that we have the variable h by itself, let's go ahead and use our calculators to get a decimal approximation for 15 sine 40 degrees. By the way, make sure your calculator is in degree mode, not radian mode, right? Because this is degrees. Okay, so the hundredths should be fine. So round to the second decimal place. Okay, so we get that the height is 9.64. What do we do with that? Remember, we're comparing the opposite side to the height. Okay, so the opposite side of 12 is greater than the height of 9.64. Okay, so let's look back at the flow chart until we get more familiar. If the opposite side is greater than the height, you have to do the second comparison. You now need to compare the opposite side to the adjacent side. Okay, so the opposite side of the given angle is still 12. The adjacent side is 15. Okay, so 15 is bigger than 12. Okay, so now let's look at the flow chart to see what this means. Again, opposite side is greater than the height, but the opposite side is less than the adjacent side. Okay, so that's going to be the ambiguous case, right? If the opposite side is shorter, that means it's short enough to where you can swing it inward and form a triangle without crossing through. Okay, so how many solutions will there be? There are two possible solutions, two possible triangles. Okay, so since there's going to be two triangles, I'm going to kind of divide my workspace into two parts. Okay, so let's do the swinging out first. Okay, so swinging out is going to look like this one over here. So let me draw it one more time. Okay, so this is the given information, right? We're given angle capital A, side length lowercase a, side length lowercase b. If this side is called lowercase b, the opposite angle has to be uppercase b. Okay, and then I'm just gonna pretty much always use A, B, C. So the third letter will be whatever's missing. Okay, so this one up here is capital C. This one down here will be lowercase c. All right, so again, last lesson, we learned the law of sines. We know both parts of A and one part of B. Okay, so we can start with the part of the law of sines that states that sine of capital A over lowercase a equals sine of capital B over lowercase b. Okay, and let's go ahead and fill in the values. Capital A is given as 40 degrees. Lowercase a is given as 12. Sine of capital B, we don't know, so leave it as the variable. But then lowercase b is 15. Okay, so I will start by cross multiplying. Right, this is a proportion with an equal sign, so we're allowed to cross multiply. Okay, 12 times the sine of capital B equals 15 times the sine of 40 degrees. Okay, so remember, you don't want to use your calculator until the variable is by itself. Okay, the B is not by itself yet, so don't round. That's going to make your answer inaccurate. Instead, first divide by 12. And now to undo the sign, you do the inverse sign or arc sign of both sides. All right, so angle B will be found by doing the inverse sine of 15 regular sine 40 degrees all over 12. Okay, so let's go ahead and use our calculators to find this. And again, we'll round to the second decimal place. Okay, so angle B will round to 53.46 degrees. Okay, and let's go and fill it in on our diagram above. Okay, so now that we know two of the angles, we can get the third by doing the sum equals 180, right? The three interior angles of any triangle add to 180 degrees. Okay, so I'm just going to do down here 180 minus the 40 degrees minus the 53.46 degrees. Okay, so that leaves 86.54 degrees for angle capital C. Okay, so we still need to find lowercase c. So we compare the C's with either the A's or the B's. The A's would be better because both of those are whole numbers. Angle B was a rounded number. Okay, so now we'll use the part of the law of sines that states that sine of A over A equals sine of C over C. Okay, so angle A was 40 degrees, lowercase a was 12. Sine of C, we do know sine of C. The C is 86.54 degrees. And we don't know lowercase c. That's our variable. Okay, so again, with a proportion, you want to cross multiply. Okay, so c times the sine of 40 degrees equals 12 times the sine of 86.54 degrees. Okay, and then we'll go ahead and divide both sides by the sine of 40 degrees. Okay, so we're ready to type the right side into our calculators. We have 12 sine 86.54 degrees all over the sine of 40 degrees. Okay, so C, I get 18.63. Okay, so there's a lot of places, obviously, where we could have made a mistake. So it's really important that we always take like 10 seconds to check our three triangle theorems. First, do the three angles add to 180 degrees? Again, this doesn't take long at all to check. 40 plus 86.54 is 126.54 plus 53.46 equals 180. Okay, so first one works. Secondly, when you add the two shorter sides, is it longer than the third side? Yes, 15 plus 12 is 27, which is more than 18.63. Lastly, is the longest side opposite the largest angle? Yes, the longest side of 18.63 is opposite the largest angle of 86.54. Is the shortest side opposite the smallest angle? Yes. Okay, all of those things are true, so that makes us confident that we are correct. Okay, and then lastly, we need to find the area. The good news is we've already found the height, right? We already know the height is 9.64. Okay, so area is 1/2 times base times height. So the base we just calculated is 18.63. The height we already found earlier was 9.64. Okay, so 1/2 times 18.63 times 9.64. Okay, so again, we'll just round to the second decimal place. I come up with 89.80, and it would be units squared. All right, so that's the solution that we're used to, I guess I would say. But we now need to do the swinging in triangle. Okay, so I'm going to draw this one bigger because otherwise it's hard to fit all the numbers. Okay, so again, this side is given to us, and we know the bottom path, but we know that this time, instead of swinging out, the opposite side will swing in. So I'll draw it like this. Okay, and now we know how long the bottom path goes. Okay, so again, I'm drawing it bigger just because it's going to be harder to write inside, but in actuality, right, these two are the same. Okay, so what should we do to start? Well, we can start the same way, right? We have both parts of A, we have one part of B. So let's do the law of sines for the A's and the B's. Okay. So cross multiplying, we have 12 times the sine of B equals 15 times the sine of 40 degrees. We want to get the B by itself. So first we divide both sides by 12. And then to get the B out of the sine function, we will do inverse sine of both sides. Okay, so let's go ahead and use our calculators. Okay, so I'll show this one. Okay, so inverse sine, remember, is above the regular sine. So second sine, inverse sine of 15 regular sine 40 degrees, close that parentheses, divided by 12, and close that parentheses. Okay, so our calculator says 53.46. And again, we wouldn't round up because the next digit's a 4. Yeah, so 53.46 degrees for angle B. Okay. So any questions? Yes, Jerry? Yeah, so Jerry noticed that visually, angle B is supposed to be more than 90. So 53.46 doesn't make any sense. Okay, and if you guys were getting a sense of deja vu, we've been doing the exact same thing as earlier, right? Literally all of this is the same. Okay, so the good news is from now on, we don't need to do the exact same calculation twice. But how do we get the right answer then, right? Because clearly 53.46 is not the correct angle. Yes, Adam?
Wouldn't you just take the side this one out? Wouldn't you take 53.46 and the other answer would be 86.59?
You mean like switch the angles?
Yeah.
So if you switch the angles, it's considered the same triangle, even though it's been like reflected. It would not be a distinct triangle. Yes, Matisse? Okay, so Matisse suggests doing 180 minus the previous answer. So that is the correct thing to do. So good job. Let me make sure everyone understands the reason. Okay, so remember back in lesson 1 of this unit, we said like for the unit circle, a 30-degree angle has a sine value of, this would be 1/2, right? Okay, but the confusing thing is this y value of 1/2 also occurs in quadrant 2. Right, so that same reference angle, if you reflect this over, all right, this would now be 150 degrees. Okay, so the sine of 150 degrees also equals 1/2. Okay, so now when we type into our calculator inverse sine of 1/2, it'll only tell us the 30-degree answer because it's following the domain restriction. But we know that 150 degrees was also a valid answer in quadrant 2. Okay, so like Matisse said, you would always do 180 minus the calculator's answer to find the quadrant 2 answer. Okay, so I'll say that over here. Okay, so again, from now on for this situation, we don't need to do this whole calculation again. You just take this angle and do 180 minus it. Okay, so I'm out of space, but 180 minus 53.46 degrees comes out to 120, where'd it go? 126.54 degrees. Okay, so that angle makes sense, right? Again, Jerry told us angle B is supposed to be obtuse, more than 90. So now it's more than 90. All right, so now the two triangles are different, right? So now we continue. We still need to find angle C and sides lowercase c. Now that we have 2 of the 3 angles, we can subtract from 180 to get the last angle. Right, so 180 minus 40 minus 126.54. That leaves 13.8 13.46 degrees for angle C. Okay, and now we can find side length C by using the C's with the A's. Okay, cross multiply. Divide both sides by sine 40 degrees. Okay, so 12 sine 13.46 degrees, close parentheses, divided by sine of 40 degrees. Okay, C comes out to 4.35. All right, so again, let's take our moment to check the three theorems. If I use my calculator to add up 40 plus 126.54 plus 13.46, it does equal 180 degrees. If I add the two shorter sides, 4.35 plus 12 is 16.35, which is more than 15. And then the longest side of 15 is opposite the largest angle. The shortest side of 4.35 is opposite the smallest angle. Okay, so those measurements are correct. And now this triangle will have a different area than the first one. Okay, so it's still 1/2 times base times height. The base is now 4.35, but the height does not change. Okay, so where did I put that animation? All right, so when you have two possible triangles, oops, don't do that. Okay, when you have two possible triangles, you see they're still the same height, right? This doesn't move. Okay, so the height is the same as before. Okay, so the height is still 9.64. All right, so 0.5 times 4.35 times 9.64. We'll round that to 20.97 units squared. Okay, so yeah, no way around it. It's a lot of calculations for this. Just remember, not all problems from now on will have two triangles. Only this very, very specific set of circumstances. First, you have to be given SSA. Then the angle needs to be acute. Then the height, the opposite side needs to be greater than the height. Then the opposite side needs to be less than the adjacent side. Okay, so only if all of those things are true will you have two triangles. Okay, so I'll just tell you, for these three problems, not all of them have two triangles. Okay, so you gotta go through the flow chart. Okay, so let's go ahead and give you guys some time to try it out. Okay, I'll be walking around if you need any help.